Smart contracts and the challenges of bad randomness attacks. Smart contracts on blockchain platforms are self-executing contracts with the terms directly written into lines of code. While they offer numerous benefits in terms of trust, transparency, and efficiency, they also introduce unique security challenges. One such challenge is the bad randomness attack. This video delves into the nature of bad randomness attacks on smart contracts, provides examples, and outlines recommendations to mitigate these risks. Smart contracts are integral to decentralized applications on blockchain networks, automating contract execution without the need for intermediaries. However, the deterministic nature of blockchain and smart contracts makes generating true randomness challenging, which is essential for many applications such as games, lotteries, and security protocols. This video aims to explain the concept of bad randomness attacks on smart contracts, illustrate these attacks with examples, and propose mitigation strategies to protect against such vulnerabilities. Understanding bad randomness attacks. Randomness is vital for certain smart contract applications. However, blockchain's transparent and deterministic nature makes achieving true randomness challenging. Attackers can exploit predictability in the generation of random numbers, leading to bad randomness attacks. Let us consider how bad randomness attacks occur. In a bad randomness attack, an attacker predicts or influences the supposedly random outcomes within a smart contract. This can be done by exploiting the predictability of the source of randomness, such as block hashes or timestamp-based mechanisms. As an example of a bad randomness attack, let us consider a blockchain lottery. A smart contract lottery game uses the hash of the next block as a random seed to determine the winner. An attacker, with the capability to mine blocks, could potentially manipulate the outcome by only broadcasting a block when its hash results in a favorable outcome for them. Here is how the lottery attack works. 1. Contract deployment. A lottery smart contract is deployed using the block hash as a randomness source. 2. User interaction. Users interact with the contract, placing their bets or making choices based on the expected randomness. 3. Randomness generation. The contract uses the next block's hash as a random seed. 4. Attack execution. An attacker mines a block and checks the resulting hash. If unfavorable, they withhold the block, attempting to manipulate the outcome. 5. Outcome manipulation. The attacker successfully influences the contract's outcome by selecting a block with a favorable hash. Randomness attack in a blockchain-based lottery system. The attack scenario. Firstly, it is necessary to understand how a lottery system operates. A blockchain-based lottery system typically relies on generating random numbers to ensure fairness in selecting winners. However, if the randomness generation mechanism is flawed, an attacker can exploit it to predict or influence the outcome. The following are the steps an attacker takes to breach the lottery system. 1. Lottery system setup. The lottery system uses a smart contract on a blockchain where participants send cryptocurrency to enter the lottery. The winner is determined by a random number generated by the smart contract, often based on blockchain data like block hashes. 2. Vulnerability exploitation. The attacker identifies that the smart contract uses the hash of a future block as the source of randomness. Since miners have control over the content of the blocks they mine, an attacker with mining capabilities can potentially influence the block hash. 3. Attack execution. The attacker participates in the lottery and monitors the blockchain for the block that will be used as the randomness source. Upon successfully mining the designated block, the attacker calculates the lottery outcome based on its hash. If the result is unfavorable, the attacker withholds the block, preventing it from being added to the blockchain. The attacker continues this process until they mine a block where the resulting hash leads to a favorable outcome, ensuring their win in the lottery. What is the impact? The integrity of the lottery is compromised as the randomness is manipulated. The attacker unfairly secures the lottery's prize, undermining trust in the system. So how do we protect against these attacks? 1. Enhanced randomness generation. The lottery system is updated to use a more secure method of generating randomness. This includes integrating external oracles or using commit-reveal schemes to ensure that the randomness source is not predictable or manipulable by any single participant. 2. Multi-source randomness. Instead of relying on a single source of randomness, the system incorporates multiple independent sources. This diversification makes it significantly harder for an attacker to control the outcome. 3. Time locking techniques. Introducing time locks or delayed reveals can prevent attackers from benefiting from withholding blocks, as the outcome would only be determined after a certain period, making immediate manipulation less feasible. 4. Participant verifiability. The system allows participants to contribute to the randomness generation process, ensuring that no single party can control the outcome. This could involve participants submitting their own random values that are combined to determine the winner. 5. Regular audits and monitoring. Implementing continuous monitoring and regular security audits of the smart contract can help identify and mitigate potential vulnerabilities. These audits ensure that the contract's code and its execution are secure against known attack vectors. 6. Community awareness. Educating the user community about potential risks and the measures taken to secure the system can foster a more vigilant and informed user base, which can act as an additional layer of defense against attacks. By addressing the randomness attack through these multifaceted strategies, the integrity and fairness of the blockchain-based lottery system are significantly enhanced, ensuring that the system remains trustworthy and secure for all participants. What strategies can we utilize to mitigate against these attacks? The following are recommendations that should be considered. 1. Use of external oracles. Incorporating external oracles can provide more secure and unpredictable randomness sources. Oracles are third-party services that feed data from the outside world into the blockchain. Using multiple oracles for randomness can reduce the risk of prediction and manipulation. 2. Commit reveal schemes. This technique involves two phases. In the commit phase, users submit a hash of their secret value. In the reveal phase, they reveal their secret, and the contract verifies it against the hash. This approach ensures that the randomness source remains hidden until all participants have committed. 3. Delayed disclosure. Delaying the disclosure of randomness sources until after critical decisions are made can prevent manipulation. For example, in a lottery, the random number used to determine winners is revealed only after all bets are placed. 4. Multi-party computation, MPC. MPC allows multiple parties to jointly compute a function over their inputs while keeping those inputs private. This can be used to generate randomness in a decentralized and secure manner, making it more resistant to manipulation. This method ensures that no single participant can predict or influence the randomness after seeing the other participants' commitments. This video is brought to you by the IoT Security Institute and the SCCISP Campus. For more information on the IoT Security Institute, please visit IoTSI.io. To learn more about SCCISP certification courses, please visit SCCISPcampus.com. Thank you.